Good evening, all. I'm Tab, or more formally Tabitha Binding, and I lead the University Engagement Programme for TRADA, which is supported by the Timber Trade Federation. We're bringing to you the Riverside Sutherland University Design Challenge. And to get you started, to learn all about timber, we want you to go to the TRADA website, go to the Don't Sign Up Here, head to the academic page and sign up in this big orange box here. You will get to read 63 units, 8 modules, all about timber. There's an infinite number of whiz sheets, 100+ case studies, and even better than that, you've got some books online. Timber frame construction, Robin is going to come and talk to us about the challenges next week. Offsite and industrial timber construction, Robert Hairstands talked to us last week, so that is already up on our video channel. Cross-laminated timber, and I think Mark is going to mention that. Structural timber elements, and a new book, Designing Timber Structures, by James Norman, will be talked about in week 4. So this is day 3 of Desirable Homes and Communities, and our chair tonight is Lynn Sullivan, and our speakers are Mark, Jay and Neil. And I'd like to hand over to Lynn Sullivan.
Hi everyone, and great to see you all, or not quite see you all. Yeah, this is sustainable construction. We've got some excellent case studies to hear about tonight. I'm an architect, and I chair something called the Good Homes Alliance, and I also sit on the Construction Leadership Council's Green Construction Board, and I've been working over the past 10 years with that board, producing some reports on how to get to net zero, really through buildings, energy reduction, and most recently in retrofit. So one of our sister organisations is the Association for Sustainable Building Products, and it just so happens that I think both Mark Siddall's, the case study he's going to show, and also Neil's were finalist and winner of ASBP awards most recently. So that's just an interesting kind of segue, really, because they are a sister organisation to the Good Homes Alliance. And alongside all the references that Tabitha's put up already in this campaign, there's also some very good stuff on the Good Homes Alliance website, particularly comparing standards in relation to a net zero target. So without further ado, I'm going to introduce our speakers in a nutshell now, and then I'll ask each of them to take that introduction as read and talk about the projects that they're going to enlighten us with this evening. So the first speaker is Mark Siddall, who's an architect who I know from Passivhaus circles. He does architecture, but he does other stuff. He does Passivhaus consultancy, he writes stuff, he does training, and he's going to showcase a really interesting project called Larch Corner. Our second speaker is Jay Cotterell, who again, I know through Passivhaus circles, and also as a Ashton judge, I know that Passive Homes won the Ashton Award. And for the UK built environment last year. So I went into the Passive Homes offering in some detail at that time. So Jay was one of the first certified Passive House designers, I think, in this country. And she's since then developed a construction system in order to scale up Passive House. And last but not least, Neil Sutherland is our third speaker. And Neil graduated from the Sutherland School of Architecture. How appropriate. And it also happens, until recently, I was a visiting professor there. So a good Sutherland-Sullivan connection there. I know Neil worked for a while at Gaia Architects, who are still one of the real trailblazers in the Scottish scene. And he also worked for a while in sustainable forestry. And since and now lecturing also in architecture and working on architectural projects, he has most recently set up MAKAR Limited, who are specializing in sustainable and timber construction. Surprise, surprise. I'm looking forward to hearing from all of you. And if I could ask you to kick off by sharing your screen, Mark. Thanks.
Okay, can you see the screen okay?
Yep.
Excellent, great. Okay, so yes, basically this is going to be a short and sweet case study of Larch Corner, which is a house that's been constructed using cross-laminated timber. If you've got any questions and things, then I'll be able to pick that up on Twitter if you're on there. And if you ever want to get in touch, then that's a good place to start. Bit of context, building on what Lynn said. I am the or one of the chairs of the Sustainable Futures Forum, and we run a Sustainable Futures Mastermind each month that works across the UK, but it's run from the Northeast. And the next one's on the 17th of February, so please feel free to come along to that. I thought I'd plug that. I'm a technical advisor to the ACB and to the Passivhaus Trust, and as Lynn said, a certified Passivhaus designer. Basically, Larch Corner is a CLT property, CLT house that Mick here lives in. And as you can see, it's timber finishes on the inside. I'm not going to dwell too much on certain aspects of it. It's quite a distance from where I'm based. I'm based in Durham. Larch Corner is down near Stratford-upon-Avon. And this presentation is basically broken down into three central parts: before, during, and after. The design process, construction, and then post-occupancy analysis. So in the before section, basically, some lessons from a poorly designed, poorly baked cake. Basically, what happened was the planning permission had been granted for a house on the site already, and I was asked to help Mick complete the project in practice. So Mick kind of got this what I would describe as a badly baked cake. All the sugar was in the wrong place, so it really kind of didn't taste very good, should we say. The planning permission, the planning application stated that the house had been designed to meet Passivhaus standards, but bore very little associated with it. And an email with the designer basically concluded that the architect believed that it was purely a construction standard, not a design standard, which is completely bogus. So, well, before I go any further, I'm just going to take you on a slight detour, so scribbles, as it were. And the key thing to recognise is that what I'm going to be showing you today is more of a do as I say, not as I've done, because of the constraints of this particular site. So the key thing to recognise here is that basically the cost of design changes escalates from, and gets more expensive as we go through a project. So it gets more and more expensive to make changes, yet it's, all of the opportunities to make those changes actually occur at the beginning of a project. So you'll see as I go into this, some of the tweaks and alterations that we made to try and improve the project, but we had some very specific constraints that we were working within, and that prevented us from doing some of the things that I might do in other circumstances. Okay, so yeah, and then normally we get into the situation whereby a contractor gets involved at too late a stage, and I'm sure that Neil's going to make some comments about kind of design and build processes and how they can be refined. For those of you that aren't really familiar, the Passivhaus is the world's leading quality assurance standard for low energy buildings, and it's basically it's basically underpinned by a scientifically derived methodology that's been verified by third-party research. So we know that it works in practice, and I'll show you some of the evidence for that as we go. I'm getting back to the presentation. So problem number one. When we're talking about a Passivhaus building, then we want really to have a good form factor, partly because this reduces the amount of heat loss, partly because this works with the economics of a building. Now, the floor plan that you're looking at right now is the floor plan that had planning permission, and it's got, well, a myriad of corners and a lot more complexity than was desirable, and that means that it's going to cost more time and labour to construct. And also you've got a lot more materials going in there. And when we start to think about the efficient use of materials, then a compact form starts to reduce all of those materials, less embodied energy, lower maintenance costs, and lots of added benefits from that as we go. So that's something that we had to consider. And then also there was an awful lot of glazing on there, which also led to some external, quite an extensive array of external shading. What we found in practice was that that was leading to some significant overheating, even with all that shading in place. Just to bounce back to the form factor kind of narrative. Basically, what we've got here is we've got buildings of different shapes and and sizes. And basically, what we can see is over on this right-hand side, then we've got some terraces detached of kind of quite complex forms in one form or another. And you can see that they've got these numbers here, these form factors, which are quite high in many respects. And as we move to higher densities, then these form factors reduce. The key thing for you to take on board is that basically the form factor is the heat loss area, so the external envelope, the walls, floors, roofs on the outside of the building, everything that's insulated where the insulation is, that's divided by the treated floor area. And basically every time that we halve the form factor, we halve the thickness of the insulation. So for a form factor of 3.9, which is Larch Corner, then, well, we would be thinking of around about 390 millimeters of insulation as a rule of thumb. And basically what we can find is, and this was recognised by Sally Godber from Warm, who are a Passivhaus certifier, is that basically, in the UK at least, UK kind of climate, what we can do is we can take the form factor, multiply it by 100, and we get the millimeters thickness of insulation. So that's a very crude rule of thumb. It's, you always have to check it. Well, as you'll see, it doesn't quite work on Larch Corner, but it's a good starter for 10. So the problem that we had was these excessive amounts of windows, which really meant that the house was very much like a goldfish bowl, particularly when you consider the moderately busy kind of footpath. It's it's surprisingly busy as a road because it ends up being a turning circle for vehicles to turn around in. It meant that living inside the house, there was you would have been very exposed and you'd have lost a lot of privacy. And as I say, there was overheating that was for about 12% of the year. Furthermore, when you start, as an architect, if you look at the floor plan, you'll probably cringe because the space planning is quite haphazard. It makes poor use of spatial kind of thresholds between different spaces and places, and it doesn't have a very well-defined spatial hierarchy in terms of the private areas the public areas sort of bleed into the private areas, and it just didn't work very well. So we spent quite a bit of time reviewing the design and trying to consolidate things. This is what we came up with. So now we end up with a situation whereby you can see that the north of the what are we saying? The top of the sheet, as it were, has been squared off. It's a lot simpler, as indeed on the left-hand side of the sheet. And then on the axes where you're entering the building now, entering the house, you can see how that's been more neatly resolved, and that manages a lot of these public-private issues in a much clearer and more thoughtful fashion. And that works very well in practice. We also had to take into account that there was no real consideration in this so-called passive house for the ventilation system. So we ended up having to think about how we carefully threaded MVHR, ductwork for the MVHR system, the mechanical ventilation with heat recovery system, through the building. We developed this concept of a service wall, which creates a spine through the building, which helps to assist distribution, as well as having attenuation to stop noise from the MVHR system getting through to habitable rooms, and also crosstalk attenuation to stop noise between rooms causing problems as well. And this is a really important issue that research by Jack Harvey Clark, an acoustician at Apex Acoustics up here in Gateshead. We undertook together, we did a big literature review, and we found that noise was the most common problem. But luckily, the acoustic requirements of the Passivhaus standard are right on in the right sort of territory and threshold there. Okay, so as I've said, it's a CLT property, and well, yeah, is wood good is the question I'd like to throw to you. You know, just to challenge some assumptions here. So bearing in mind this is a CLT property, what we're thinking about in terms of substitution of resources. So it's not brick, it's not concrete. So this is a beneficial substitution. We have responsible sourcing is a key thing, of course. If it was timber from old growth forests or in Russia or somewhere, that wouldn't be a good thing. But in this case, we are using sustainable timber, in this case PEFC certified. There's also a game that people play in terms of what I'm saying here is the danger of zero ambition. And this is when you start to play games, you start to say that wood is zero carbon. It's not. When you burn it, it has carbon emissions. And it's basically, for as long as the building's locking up the carbon, that's a kind of beneficial thing. But it's a bit of a fool's game to start to try and play a zero carbon, zero sums game with the building in that respect. And you'll see later on how I have deliberately excluded that from the carbon emissions kind of analysis. Then we've also got the one whereby, as we want to have more timber, increased timber use, because you will sequester carbon for a limited period of time. Whether that's better or worse than some of the consequences of mining stone are to be debated. But if it starts to threaten farmland that that's otherwise used for food, then there's certain tension. So we need to think about how we responsible forestry as a whole, not just as a is it certified PEFC or not. It's what's the land use before that. And then as I tried to explain before, resource efficiency is key in terms of thinking about formal factors so that we don't waste material, we make proper use of it. And to tell you the truth, in this particular case, it's a bungalow. Did it need CLT? Well, the answer is, in truth, the answer is no. We could have created a very elegant structure that would have satisfied the requirements. We could have reduced the quantity of timber that was used in this particular case. But ultimately, it's one house and it's what Mick wanted, and I respect that. And it's an amazing house, beautiful on the inside. But we've got to be aware of those tensions. Toxicity, timber is generally good, but there are secondary chemical reactions that can take place, which can have an impact on air quality. So it's to be aware of, not necessarily a major issue. We've got fire safety issues that need to be considered, of course. In this case, we've got a sprinkler system so that we can have the exposed timber on the inside. And then, as I say, there's the use of resources and end use of resources. And any kind of carbon emissions that arise from burning timber. So in this case, what we've done is there are over 2,000 screws holding the house together. So it has the potential to be reused in some form, but we've got to recognise that that's wishful thinking, and we can't say that that will happen in practice. We don't know. So what we can really say is that wood isn't necessarily perfect, but it is probably the least bad of many choices, I think. In terms of CLT, it's a special, and I've pinched a couple of slides here from a presentation that Mick did for house planning help. Basically, CLT is a specialist product, and it comes in laminate layers, and it's basically large slabs that can be craned into place, and I'll show you some examples of that coming up. In this particular case, the product came from a company called Novatop. So how do we construct a CLT house? Well, first of all, it's got to go on some foundations. And in this case, what we did was we put the house on a continuous raft of insulation. And then there's a concrete floor slab. Now, everything above that level is timber. So this is the should we say, the guilty sin in terms of this is where the petrochemicals are. And this is where the concrete is. They've both got some fairly high emissions associated with them in a specific sense. And the system goes together very neatly. It's all prefabricated off-site in a factory, so there's minimum amounts of waste, and then you basically create this permanent formwork that you can pour the concrete into. The timber frame, the CLT is then craned down onto sole plates in this particular case, and that is then held down onto the floor slab with through a range of different means. In this, you can use angles and other screw fixings and the likes. So day one, the walls went down. Day two, the roof started to, the roof went on. And then day three, there was an airtight membrane and airtight taping that went over the entire CLT. Now, in most of because this house was being constructed in the summer, and because it's a single dwelling, there wasn't the risk that it was being exposed to the weather for a prolonged period of time. So we actually taped the joints on the CLT. There was some glue in there as well that went in as part of the manufacturer's construction process that also contributes to airtightness. And that's where our airtightness was. In other circumstances, if it was a bigger building, you probably want to cover it with a membrane, so just to protect it from weathering. And in fact, that's what we did do on the roof, but not on the walls. So yes, this membrane went down over the roof and all the joints were taped. The MVHR system, I just want to flag it again. In this particular case, you want to make sure, or in all cases, when you've got an MVHR system, you want to make sure that the intake and the exhaust ducts are very well insulated with a vapor-tight insulation. And in this case, the product that we use is a product called Armorflex. That means that we don't get condensation on the surface of the ductwork, because that's pretty much running at outside temperatures in the middle of the winter. That's when we can get cold surfaces and condensation. And on the outside, we've got this special little terminal which helps to jet the exhaust air out of the building while sucking the fresh air in. And we haven't got a risk of mixing because of aerodynamics. And it's proven to work very, very well. We did a completion, well, as with all passive house buildings, we had to do a blower door test. And in this particular case, what we found was that it was incredibly airtight, to the point whereby we had to send the blower door fan away for recalibration so that we could actually get a legitimate certifiable result. What we found was that the air leakage is basically 192 square millimeters, which to help you visualize that is basically the square on a 1 penny coin. Okay, so that's what we've got. You kind of acid etched on there with a bit of tomato ketchup and the masking tape. But that gives you an idea about how, that. So if you gather together all the leaks in the house, it fits on onto a 1 penny coin. If you look at building regulations, what you'll find is that well, the Canadians worked out that they have an air leakage of, they have a standard air leakage of around about 3 air changes per hour at 50 pascals, and that's the equivalent of half a door missing from a house. Okay, this house is 244 times more airtight than required by building regulations, and 16 times more airtight than required by the passive house standard. So it has an air change rate at 50 pascals of 0.048 air changes per hour. So there we are. So it's the most airtight home in the UK, as far as we know, and it's the third most airtight home in the world, as far as we've been able to figure out as well. So there was a little celebration at the end of the testing process there. The house on the roof and on adjacent shed, there's a 4.3 kilowatt peak photovoltaic array, which contributes to well, in building regulations terms, this is a zero carbon building. Okay, so life after the fact. What's it like in reality? Well, summer comforts. So what we did is we put some data loggers into the house, and we measured inside and outside temperatures and humidities over the course of a 12-month period. And this is what we've found when we've been reviewing the data just this last week or so. Basically, the living room goes over 25 degrees Celsius for 10% of the year, and PHPP, the Passive House Planning Package, suggested it might go over 25 degrees Celsius for 9% of the year. So in that context, it's working, but several things to recognise there. I'm not comfortable with it being that 9%, not 10%. again, we were hamstrung by the situation that we're in. I like to work with it. Good practice would say you're trying to get that to less than 5%. There are things that we could do in the future. We actually stripped back all of the shading. In this particular case, there's things that we can do to try and to introduce that that would help mitigate some of that in the future. But all in all, it's working okay. And Mick himself is very, very happy. So as long as the client's happy, then it's a good thing. One of the things to recognise is that all of the if we look back at the previous design, in this case, all the windows are sized for daylight. Okay, so we've used the Passivhaus ribbon daylight calculation tool to calculate the amount of daylight in the individual spaces, and there were some that failed marginally in terms of not having very high levels of natural daylight, should we say? But all in all, we're in the right sort of vicinity, and we've got these levels, or we've got this issue in terms of summer comfort, whereby the house is going over 25 degrees Celsius for 10% or one room is going over 25 degrees Celsius 10% of the year. So what we could do is we could review whether whether we could cut back a little bit on the daylight to reduce the solar gains, or introduce some solar shading. Those are the kind of things that we can think about. I had the privilege to work with Professor Wolfgang Feist and other colleagues from David Johnston from Leeds Beckett University and colleagues from the Passivhaus Institute on a paper looking at the performance of Passivhaus buildings and how they perform in practice. This is the product of a lot of that research. Basically, what we can see is that in the UK, we have a performance gap whereby dwellings are not delivering the energy savings that are expected. This graph shows on the bottom the calculated demand, the theoretical, the design aspiration, and on the vertical axis we have the heat consumption in practice. And the red line shows that the perfect line of fit. And I kid you not, I plotted the graph for Larch Corner. And what we find is this green dot arrived, and it was basically, we calculated out that it would use 14 kilowatt hours per meter square per annum. And in practice, what we're finding is it's using 14 kilowatt hours per meter square per annum. That's, as a one-off statistic, this is quite surprising. You'd normally expect it to be higher or lower, depending on how people live in the buildings, but it's very rewarding to see that it's actually achieved that in practice. The heat pump, a monoblock air source heat pump, is not performing quite the way that we'd have expected, partly because the house is actually occupied by one person, and therefore the domestic hot water load is not as high as it might otherwise be, and therefore the coefficient performance, which is the measure of the performance of a heat pump, is not as good as we would like it to be. But it's also not a million miles out of sync with some of the heat field trials that have also been done, and there's a link down here that you'll be able to access at a later date. Finally, basically, what do we find when we've gone through all of this, when we compare the Larch Corner to the RIBA 2030 challenge? Well, we've not really gone into the potable hot water measured in practice. Measured embodied, we've calculated the embodied carbon, and the embodied carbon for a CLT home, where the insulation, everything above DPC is also wood-based, where it's clad in timber, it's got a green roof, it has got the photovoltaics associated with it, and we've got the carbon emissions are 383 kilograms of carbon per meter square, okay, as the embodied carbon. So that means that we are somewhere between I'll say this, we're about 2027 on the RIBA climate challenge. We're not quite getting to 2030, even with all of this thinking going on and all these materials and specifications. In terms of operational energy, the measured electrical energy in use on the meter, effectively what we've seen is 43 kilowatt hours per meter square per annum, and that includes an electric car, next to an electric car, And so that's got to be corrected a little bit, but again, we're into this 2027 sort of territory, not 2030 at the moment. It's also worth recognising that 36 kilowatt hours per metre square per annum were also exported, but it would be a bit of a zero sums game if I tried to lock that out of the operational energy. That would be a fudge and a bit of a lie in my view. So whilst it's doing very good things, there's some issues there. And as I say, with the operational energy, the house is occupied by one person. If you put more people in there, then it's then the energy use in the dwelling is going to increase. So how people are actually going to achieve the 2030 challenge of somewhere between 0 and 35 kilowatt hours per metre square remains to be seen. Okay, so that is some final points. Because the house is drawing electricity from the grid in the winter to help satisfy space heating demand, electrical demand and things, this so-called zero carbon house with quite a significant photovoltaic array is still responsible for 3/4 of a ton of carbon dioxide emissions each year. And now as the grid gets cleaner, that will reduce. But just don't believe all the stats when people say that homes as it can be zero carbon using calculation methods at least. So I'll leave it to you to decide, but whether Larch Corner passes or fails the 2030 challenge. So there we go. If you'd like to see a little bit more about Larch Corner, then go to passivhausesecrets.co.uk. There's a documentary there, and then there's another documentary about another project I worked on called Steel Farm, which won the 2015, I think it was, Passivhaus Awards. And then there's a 3-part documentary series if you want to put in your name and email address. That's me done, Lynn. So thank you.
Brilliant job. Thank you very much, Mark. And you kept to time, which is really excellent. As we've got just a couple of minutes sort of spare, there's a few questions on the chat. I don't know if you want to take them now, but very specific ones. So someone questioned the embodied energy of all that insulation and tape. I wouldn't have thought the tape has a huge embodied burden, but you didn't actually say how much insulation I think you added to the CLT on the external walls. So.
Okay, so we had, go from memory, 360 millimeters of insulation between engineered I-beams that were attached to the outside, and then we had an extra 80 millimeters of insulation on the top of that. So it is significantly insulated. All of, as I say, is with wood fiber based insulations. Yes.
Great.
The I removed some of the slides that were kind of getting into more details about the specifics, but I'm sure that can crop up at another point.
No, that's fair enough. The other thing, perhaps I could ask a question, which was about your. I've been tracking the climate change committee's prognostications on particularly on retrofit, but in general relating to heat pump performance. And I think they're talking about an average of 3, which certainly on retrofit seems way to go. And I just wondered if you had any further observations on your COP of 2.6, I think it was.
I think that the key. I think one of the biggest issues here in terms of how it's performed in practice is that Mick, being the only person living in the house at this particular point in time, means that the domestic hot water use is quite low. It is a CO2 based heat pump, which is actually very good for generating hot water and works quite well for space heating as well. So we would have expected different performance under other circumstances. So part of it is a quirk of the particular dwelling, shall we say?
Yeah, because I mean that could have affected your overall energy.
Like rolling a dice with a heat pump.
Yeah, I mean that could affect your total energy used in relation to the 2030 targets, couldn't it?
Yep.
Anyhow, well, that's really, really great. Thank you very much indeed, Mark. And any further questions, please save them up for the end, because I think we've got a few minutes at the end as well. and please post any incidentally on the chat. So, okay, so that now I'd like to ask Jay Cotterell of Passivhaus Homes to talk about her system.
Thank you very much, Lynn. I'm one of those architects that's gone a bit beyond and developed this, what I'm calling here a component system called PH15 to achieve a passive house level of performance with low carbon materials. And it was all about seeing that it would be a good way to ensure rapid and safe transition to much better housing and scalability, as Lynn has already mentioned. So I'm going to talk about a particular project, Akerman Road, but I'm talking about the benefits of a component system. And because we use this same way of constructing over and over, that can be a useful source of information about what we've learned. So I'm going to go through and give you tips as I go through. So we start here with, just trying to get to the next one. There we go. So this is the project that I'm going to sort of link to, which is Akerman Road, which is social housing. It was designed by Anne Thorne Architects. It was built with our system, PH15, and the client was Lambeth Council, so it was social housing. It was quite a few years ago now. So they were quite out there, willing to take a risk on innovation. The reason they were willing to do that was they had a very fast time turnaround, and they did want to trial passive house. So they accepted a perceived risk with us, but went for it. Luckily with the Sutherland site, you've got a council who are asking for innovation. So this is the sort of thing they're really looking for. Mark has talked about some of these things, which has helped me. So you're looking to meet the RIBA 2030 challenge with this competition. So initially you're talking about this target here, which is directing you to rigorous application of passive house principles. So with our system, we're talking about U values generally in the UK of around 0.1. And then this one is directing you to timber frame and natural insulations. And we use a palette of low embodied carbon materials. And of course, with the system, what we're trying to achieve these with best practice. So that's our aim. We're slightly unusual with our system because we're not just a timber frame. We're looking at all the components that you need for passive house levels of performance. So you're looking at the fabric, you're looking at things like air tightness, but you're also looking at windows and MVHR. And you have to bring all these things together if you want an assured outcome. So the tip is, if you are designing for this competition, you also need a strategy to deliver all of these different elements if you're going to ensure the right performance. This is a sort of palette of materials we're talking about with PH15. There's a little bit of sheet squill. There's wood fibre, loose wood fibre. There's wood fibre in board form. And there's a lot of laminated veneered lumber, which you can see in that picture that I've labelled. And that is a very efficient way of using your wood, and it's also very strong. The sort of key component of our system is the I-joist. So Mark has been talking about CL2, but our sort of champion timber product is the I-joist, which I've got here in my hand. So this is what I champion, and it's basically made with laminated pieces of timber, as you can see on the flanges, and then there's a small web in the middle. So it's a very small section timber. It's at the opposite end of the scale of the CLT of the previous project. So it's aiming to use minimal amount of timber and achieve maximum strength. And it's really deserves an award in itself, the I-joist. It's got this web that spans across the wall or the roof structure, and it's only 8 mil thick. And what that enables is you get a very low timber fraction in the structure. So typically with our system and with this particular project, this is the frame for Akerman Road, we're getting an 85:15 ratio. That means only 15% of the timber is structural. The rest of it is left for insulation. And you can even get it down to 90-10, where only 10% of it is structure and the rest of it is insulation. And that makes it thermally very efficient. So a tip here is for you guys, know why you have selected your particular timber solution. So the challenge with a really good simple is to have simple transitions. So everywhere you have something like a wall or a roof or the ground, you've got to make the transitions between the different building elements as simple as possible. So the system, a good system or a good design, is going to ensure that you get contiguous layers. And by contiguous, we mean that they are continuous and connected and aligned. So every junction should ensure that the airtight layer is continued and that there is no thermal bridge. That means the insulation isn't interrupted either. The most difficult one to do, Mark showed you a bit how they did it on their project. It's where the frame meets the ground, and that's because there's a conflict, the biggest conflict between structural needs and insulation. So with our system, we're able to have had all of our details pre-calculated. This is a psi calc you're seeing here, showing that we've achieved a negative psi value. So you're actually getting credit for that detail. So we're managing to manage the loads and not break the insulation. I haven't got time to go in exactly how that's done, but you get the idea. So we went for not a panelized system, but what we call a flat pack system. And this is how it arrives on site. So all of the elements are pre-cut using modern methods of construction. And then it's screwed together on site with UK local carpentry teams. So we like this for various reasons, but one that I would say is it does enable small teams to erect houses. So it doesn't push out the smaller builder or even somebody who wants to do a self-build. So you can go all the way from big construction companies to very small teams using this system. The basic wall build-up is here. The pink is what we supply. And then you can see there are 4 different ways of finishing the outside illustrated on this drawing, but there are a myriad of ways you can finish it. So it's quite interesting to think about that. The elements on our wall, I'm just going to go through quickly. The basic build-up of our wall and roof is the first layer, the blue layer that you see there, it's something called a Durellis board. And it basically acts as the vapor block. It stops moisture moving into the timber frame. It also acts as a guaranteed air tightness layer. So it's acting as the air tightness surface. And it's also the racking board. So it's providing the racking strength to the frame. So it's it's working really hard, that one layer, and doing 3 functions in one. Inside, you've got your I-joist, but mainly it's insulation. So it's mostly wood fibers with a bit of sheep's wool. So it's vapor permeable insulations and low embodied carbon and recyclable products. And then on the outside, you've got a wood fiber board, which is very vapor permeable. So it allows any moisture to dry to the outside, and it also enables you to over insulate all your glazing, which is very important to enhance their performance. So 2 tips here. Think about your external finishes and their environmental impact. And there may be some of these finishes with much higher embodied impact, things like brick, for example, and others which are less. And just think about, maybe there's ways you want to add design value, because design is very important, but maybe not do those things everywhere. So that's something to think about. And also you must always ensure, in my experience and my knowledge, that a timber frame is vapor permeable. It's a natural product, it needs to be vapor permeable. So here we see the frame in its sort of raw state and how simple the sort of details are. And each of the junctions comes with some simple drawings for the basic shell, which then are enhanced by the designer. So there's lots of ways you can treat the different junctions, but the basic junctions are very simple. We also cover even smaller, finer details like how the windows and doors build in, because if you do those well and you optimize their performance, you then reduce pressure on cost and materials. So it's being elegant about your solutions. We are very keen on training and support. So every time we do our system, we are trying to put in, we are putting in an element of training and technical support. And because we're doing it again and again, we can really get good. I think we've got very good levels of information for the contractors. So this is like an assembly book that goes with the frame and the system. And we try to move away from 2D graphics to 3D graphics. So it's with you can see a very simple step-by-step instructions of how the thing goes together, which is, I think, really useful on site and sort of makes reaching equality easier. Here you can see a particular, and this is another project where you can see that the I-joist and flat pack solution, it really does allow flexible design. So you can really bespoke it as a designer. You can see some quite complicated shapes being created here with the system using the I-joist and these birch ply connectors that we use. And this was actually airtight tested just about a week ago, and it got 0.28 air changes per hour. Not so low as Mark's with the CLT, but for a system like this, this is an absolutely excellent result. And this guy here, UK carpenter, never heard of Passivhaus before, but achieving absolutely top end results with a simple solution like this. We offer things like LVL, little extra bits. You can get LVL with higher quality that you can then use for details to leave on display in the finished building, and that's what's being shown there. That's going to be on display at the end. So flexible design and being able to have a solution that fits with UK local carpentry skill. The airtight layer should always be simple, be visible, and here you can see how simple ours is. We're always using this robust board, and we're using mostly it's just a single tape that's being used, and it means everyone can identify the airtight layer. It's all visible on the airtightness test day. And I just wanted to make a point about value. Someone at the very beginning of the launch of the competition said, you don't always want the cheapest. You know, sometimes paying a little bit more for something is important in terms of durability. And for me, if you're going to use timber, it's a precious resource. Mark touched on this. It's a precious resource still. And therefore, the airtight layer is doing such important function to spend a little bit more on better tapes. These ones have been 100-year tested, and a really good airtightness board for the client is money well spent. So my tip would be, you want to ensure you're delivering durability, not cheap frames. And we really shouldn't be talking about 60-year life. We should be talking about 100, 120-year life. When the frame is up, it's filled with a wood. It's basically just loose fibers of wood. This is the sort of machine that blows it in, and there's a pressure testing equipment, and you can see it maybe isn't the best, most comfortable task to do, but it is quite quick, and it does avoid fitting fatigue. If you have a frame where you've got to hand cut loads and loads of insulation to fit tightly into your frame, you're going to have quality degradation. So modern methods of constructions come into place where you can do something like this and do it quick and do it effectively. And here you see them on site. Mostly it's done through the airtight layer. They make little holes and then they're patched up afterwards. And I'm very keen on the fact that our system can go low as well as high. So it can be done with very small teams. So if you're talking about sweat equity, that means people putting in their own labour. I like the idea that if you've got 1,000 homes you're building, that some of that could be given to people who are just building 1, 2 or 5 houses, and to smaller contracting teams, and not just eaten up by the big boys. So you want a bit of all of those things, in my opinion. And here you see 2 people building a house, one with no experience and one who's a good carpenter. And with the help of one other person, occasionally, they are building that entire house. And you can see how neat it is on site because the fact it's all been pre-cut, because it's all simple 3D drawings. And the picture on the end is another of our clients who did it. One carpenter and one client with one person helping, and they've done a fantastic job doing that. So in terms of housing, which is so expensive for young people, why not have some creative ideas how we can start, putting labour in and getting some lower cost housing for younger people at smaller scale? I think that's something would be my tip to start thinking about as students. Right at the other end, if you've got larger contractors involved using a system like this and you're doing multiples and you want to do quick, then I would suggest, why not start thinking about this flying factory type arrangement where you have a factory on site and you have it covered and you make sure you've got good working environment for the workers, and then you can have heavy lifting equipment and you can lift the bigger panels once they're put together, and you could have apprentices. I think this is what Sutherland is interested in this. You could have an apprentice school going on and teaching people while you're going through this process and putting things up sort of at maximum speed, really. So right from one end to the other, there's interesting options there. MVHR, as I said, we're not just a frame company, and you need to think about the MVHR. Mark had some nice slides there and gave you some good tips. So here again, you can see we do a slightly different distribution system than Mark. We do what's called a radial system that avoids some of the crosstalk problems, but you do have 2 extra distribution boxes that you can see, those grey boxes that you have to find space for. So it's absolutely critical. It's not a side issue. It's not a sideshow. If you don't, it's an integral part of the whole thing. And it's what ensures that there's high quality indoor air. So we're trying to build healthy houses, and that means you have to have healthy indoor air. That means you have to have a well-designed MVHR unit. So again, tip, think about MVHR early in the design, learn something about it if you don't know something about it already. Keep the outside run small, Mark made that point, and allow enough room, it's very important. Then we also do windows. You can see the windows there, they're quite a sophisticated element. They're very heavy, they're not like our normal windows, and that's because they're thermally the weakest element in any building. That's why we have to invest to improve them significantly if we're going to perform at this level. They are the thing we invest most in. So they are usually at least 3 times the cost of your wall and roof. So every time you put window in, you're trebling the price of your overall project. So remember that as a rule of thumb. Secondly, they're the source of any overheating risk you might be creating. And if you create an overheating risk, you then have to shade, and that shading is probably going to cost you even more money. So it's not that you shouldn't shade, it's not that you shouldn't have glass, it's just that you should be aware of it. And the problem is if you're not, and if you design it badly, the problem will escalate rapidly over time. It won't get better, it will get rapidly worse. And in 30, 40 years' time, something that's overheating 5% today could be overheating 15, 20% in 30 years' time. And if you're building for 100 years, you're going to have a terrible problem in due course, and someone's going to have to sort that out. And it's no longer going to be a sustainable home, and it's not going to be healthy for the people who live in it. So do not overglaze. Sally Godber said this 2 days ago to you guys. If you were listening, she did a very good talk. Do not overglaze. If your house is too hot, it will not be comfortable or healthy. But if you have to shade, and sometimes you do, then there's all different sorts of ideas. You know, you've got fixed grading, you've got verandas, you've got external blinds, you've got the option to use low G glass, which just stops some of the sun getting through the glass. And you should use robust energy modeling software to check. So PHPP does that, but you need to use it very carefully. There's going to be a new tool out very soon from the Passivhaus Trust that's going to help you to do that in a careful way. So watch out for that. And of course, you must remember that we're stress testing for future climate. We're going to have many, many more hot weeks in the future. And, you know, we had this quote, this is from Akerman Road, a lovely quote about the health benefits of living in this house. If we got the overheating wrong, we wouldn't be having those quotes anymore. So watch out. And we have a very low target as to try and get under 2% of annual hours of over 25 degrees. That's a very ambitious target we set ourselves. So this is our design guide. This is for architects and designers. So anyone who's designing a house can use this to sort of say, oh, we're going to build like this. And so it gives you the sort of basic data that you need to be aware of. But we're looking, just go through these very quickly. We're avoiding reinventing the wheel every 5 minutes, and then the possible complexity of doing that, added complexity. You are protecting the specification, so when you start at the design, it's protected all the way to the completed building. We're retaining design flexibility. We're reducing the fear factor. I've never failed an air tightness test, and that's a very reassuring thing for a contractor. We're optimizing low embodied carbon materials. We're minimizing cost uplift and waste. We're ensuring timber safe details, and that's the management of moisture. We're minimizing the overheating risk. And then this final point, which is we're delivering training and upskilling locally, which I think also in this particular project for Sunderland Council, and I think for a lot of councils would be important, that we keep some of the economic benefit local. So if you want to know the sort of what you achieve. Here's Akerman Road, and the difference, if you built it at masonry on the left-hand side, you can see the difference of jumping from a sort of masonry equivalent down to a timber frame. It's a big improvement in carbon emission. And then on the right-hand side, you see the difference about what fuel source you choose. So the 65 tons is if you choose gas to heat those houses, and the 12 tons if you go for electric with a heat pump technology, which actually Mark was doing in his house. But in this case, it's high occupancy, very different from Mark's house, which is very low occupancy. So it makes it very efficient. And over time, electric will be less carbon intense. So the emissions will get even smaller over time, which is why we encourage people to go that way. In terms of the 2030 carbon challenge, you can see the first on this graph, the right left-hand side is the sort of carbon emissions we might expect from a standard house today. And we're trying to encourage people down here to an air source heat pump with PV. This is just for the shell, so this doesn't include all the finishes. So it would get, Mark is quite right that this 2030 benchmark for embodied carbon is a little bit ambitious, but we're talking about the shell here. I think that's being looked at now anyways. But we're trying to get people to this future, pH 15 future. And what is that? Well, you can see here that for us, most of our carbon is in the groundworks. And I saw a question about that pop up a little while ago. So a big chunk of it is in the groundworks package, in that concrete and, as Mark mentioned, petrochemicals. So can we encourage people to go somewhere like this? And we've got clients now looking at adopting this. We've got one housing authority looking at maybe going this way if they can make it work. So here we see a lovely new thing on the market. It's called Rapid Root, and they're using this interesting spiral technique to do a modern take on a pile. It's low impact, and then you create a frame underneath, and then your building sits on the top. And it means you can take all that concrete, all those petrochemicals out, and you can put a timber cassette floor in. The challenge of it is that it raises your floor up out of the ground, and you've got to get level access. So my tip here is, why don't you think about something like this, and can you come up with creative level access design solutions for something like this? Because I think this is where we need to be going. If we really want to talk about these very low embodied carbon solutions, this is the way to go. Trees, a little bit about trees. Yes, we love trees. Does it mean we can use trees as much as we like? Is it always good? You know, 160 square meter house, which is one of these houses, is 50 trees we're talking about, even when we've used it very effectively and efficiently. It's a lot of trees. So it's very important we use the whole tree, and that we design for long life, that we use, make sure that it's sourced from best practice managed forests. And even if they're marked FSC and these other marks, doesn't necessarily mean best practice is being followed. So we do need to be very careful still. And we need to aim to recycle and not incinerate. At the moment, we're incinerating a lot of timber. So that's another challenge for the future, that we've got to stop this assumption that we're going to incinerate. And a tree is best left in the ground. So this is just saying, doesn't mean using more timber is better. It's not. So use timber appropriately for the task. But if you do use it, you know, for a typical modest house, you're talking about saving at least 30 tons of carbon being emitted out into the atmosphere. So it's fantastic in that way. It is a very good way forward, and why it's being recommended for you guys to go this way. Cost, very briefly, I won't say too much about this because Mark talked very well on this, but we were right down here for this project. So all these blue dots are pH 15 projects, and because of the form factor, which I don't now have to explain to you because you know, because Mark talked to you about it, this is a very good form factor of 1.8 Akerman Road. But you can see there's another project which is more like Larch House, which is right at the other end. And you can see that the price differential for pH 15 is jumping from 450 to 750 pounds a square metre of the internal floor area. So it's not like, we're not talking about little cost differentials. We're talking about very significant cost differentials according to the form. And he showed you this diagram. So you need, if you really want to think about economic sustainability for affordable houses, then you need to be down towards below 2, in my opinion. You need to be starting to get down there. And you can see that's looking for something like an I-joist. You can probably do up to sort of 4 stories in an I-joist. After that, you're jumping to Mark's idea of CLT, probably. So the tip here is to avoid complexity. Remember that replication and simplicity can be beautiful. And this was the point that was made by Goldsmith Street in their talk yesterday. You know, they've done a fantastic looking scheme, but if you look at it, it's quite simple and there's lots of replication. So don't shy away from it. Doesn't mean you can introduce a little bit of complexity, but remember that replication and simplicity can be great tools. More surface area just equals more heat loss, just equals more cost. And then you've got to use the PHPP software. This is the final output page from Akerman Road, and you can see how low the heat demand was because it's a very efficient shape. So well below Passivhaus standard, that's just above 9 kilowatt hours per square metre. You know, so yeah, you've got to model. So here's the finished house, and I would say, have we done well on the operational carbon? Yes, and I think that's greatly helped by the form factor. And then embodied carbon, yes, we've used a very good range of natural materials. We could have done better with that groundwork solution that I showed you. Economic sustainability, yes, again, delivered by the low form factor. And this is actually heated by gas, but if you were to swap to a better fuel source, it would have done even better. So that's that. Now, I just wanted to talk about the design and say one good point and one bad point about the design. So here we have the good point, I would say, is they've used brick cladding, but they've used it sparingly and appropriately. So it doesn't mean you shouldn't use some of these products, but you need to think how much you use and where you use them. And I think the brick there that they've used is full brick used in the porches that are outside the thermal envelope that just tie it into the street scene. And they've used some brick slip at the lower ground level around the entrances where they needed some robust materials. So they've done quite well, but then they've used lime render elsewhere, which is a much cheaper and a lower embodied carbon material. So that was quite a clever design choice. Bad design was there is unshaded west-facing bedroom windows. Now, this was because the council would not allow us to put shading devices on. You're not going to have problems with this, with Sunderland and this competition, because it's a much, hopefully everyone is going to be much better aware about what's needed. But all we could do was put low G glass, which reduced some of the solar gain. But we have done post-occupancy evaluation on this building, and it heats up more than we estimated, even though we were very robust about it at the time. So we are even more robust than we ever were now. The solution, though, if we were designing this for the competition, for example, is that we would be putting external blinds into those top floor bedrooms, and then that would solve the problem. I give these two, it's just a little bit of a page about saying this archetype project, I put it on here, not because it's built out PH15, but it could be, but they use a very similar palette of materials, but because it's a very simple shape, that building, if you see it from the outside, but it's beautifully designed, and its palette of natural materials is very aesthetically pleasing, and the lighting is very pleasing. So as a designer, when you're coming up with these schemes, you need to think about good design matched with buildability and deliverability. And that shows that you've reached a level of skill. Over complex design is not skillful. So, and delivering, you know, very, very fancy looking designs that are not buildable or very difficult to build, I don't think is the skill that we need at this point in our history. So I put that to you as younger, I presume most of you are younger designers. I will promote my own book, which I wrote some years ago with Adam Dadabai. So if you want to know a bit more about Passivhaus, then it's still a good read, and it'll give you all the basics. And we've actually sold over 10,000 copies of that now. I think that brings me to the end, and I am really excited by this competition. I think it's been set up brilliantly by Tabitha. I think the level of speaking that you're getting is very high, and I'm really fascinated to see what sort of proposals come out from it. So I look forward to seeing the outcomes. Thank you.
Brilliant, Jay. Thank you so much. That was really, really loads of information. Actually, one of the recurring questions was, is there a PH 15 guide for designers? Is that handbook you showed,
Yes.
you know, how to use your system?
Yes.
So you've
So if anybody wants
away
one,
all
then
your secrets then.
well, the whole idea is to share your secrets, isn't it? So yes, we do have a guide that's available, yeah, that you can get hold of.
Great. Okay. Well, I'm sure lots of people will be using that. I had a couple of other questions. There was a recurring question about low carbon concrete, but I think I'll take that at the end because that's probably a general thing to ask the speakers. You said at the beginning this wasn't panelized, but it's flat pack. I think there's some misunderstandings about the use of those terms. Could you just define your terms a bit better there, or
So
more?
for panelized, I would be indicating that the walls and the roofs have been made up into large panel sections. They might be 3 meter, 6 meter wide, and they're coming to site. They might be, some people do them with the windows in, as far as that, and insulator. Some do lesser, just the main frame put, but they come in very large chunks, and then they're craned onto site, so that the erection period on site is much quicker. Whereas, as you saw, ours was coming on the back of the truck, so it's been pre-cut in the factory. So there's been some work has been done off site, but there's more work to be done on site because you've actually got to put all the elements together on site with local labour.
Okay. That's probably better for the idea of the flying factory as well, isn't it?
Yeah, so that's why, you know, if you wanted panelising, we would be promoting the idea of doing it on site in a flying factory arrangement.
Yeah. Does your system come with kind of lots of prompts about testing as you go along? Because I thought with blown insulation, do you have to, you know, do you do a check on how contiguous that is?
We organise the insulation. So one thing we do, well, there's two things we do. We organise the blown-in insulation. So we use, because we don't let anyone do it because it needs skilled operatives to do it. So they call it off from us and we organise it. And then the second thing is we include in our system the airtightness tests. So we retain, so that the first airtight test is organised by us and we present. So at the point that it's airtight tested and it passes below Passivhaus is when we sort of hand over.
Just a question on the chat that's just come in, which was questioning whether you made a conscious decision to use plastic ductwork instead of galvanized, but I guess that's very much a cost thing, isn't it?
Well, it was because of the rate. It was the difference between it wasn't the choice between plastic and metal. It was the choice to do a radial system. That means that the air is being sent to each room individually, so there's no branch system. So it's easier to commission and make sure you get the right amount of air in each room, and it's also less likely to get crosstalk between space. So it was about that rather than the plastic versus metal. Okay,
thank you very much. Okay, I think we'll move on at this stage, and then maybe pick up some, as I say, some more general questions if we have time at the end. So could I pass over to Neil Sutherland now, who's going to talk about his award-winning project?
Yeah, hi. Thanks very much, Lynn. I'm certainly enjoying the evening. So hi everyone, I'm speaking to you from Inverness. I'm just on the edge of Inverness. Just check the time. Okay, so 35 minutes or so. Yeah, so I'm not a Passivhaus expert, but the project I'm going to talk about later on in this presentation is one of a trilogy, because it also is a certified Passivhaus project. Hang on a sec, just make sure this works. Does everyone see that? Struggling to go forward here. That's interesting. Okay. Normally there's a little arrow at the bottom you can go forward.
Yeah, there is. Can you not see that?
Yes, I do now.
Cool.
Here we go. So, yeah, Neil Sutherland. I'm the director and founder of an organisation called MAKAR. We've been in existence for a while. It's actually 18 years, and 10 years before that, I was a design consultant. And then I've forgotten I was an architect. Actually, Tabitha reminded me. So I qualified about 10 years ago. And since then, we've built up an organization here, which we've built around about 200, mainly houses. We do other things as well. And we have about 50 people at the moment. We're growing, and we manage around 15 to 20 home deliveries per annum, and we're on around about 5 million turnover at the moment. I'm going to talk about a number of things, not just the house that I was asked to talk about. I thought, given the kind of circumstance, I would cover a kind of slightly wider kind of theme range. So I'm going to talk about the kind of big picture as we see it. Something about timber and timber products, because although that's been covered quite well in some respects by the two previous excellent speakers, we have a particular approach to this up in Scotland, I guess. Scotland has 2/3 of the standing timber resource of the UK, and we've been in about it for quite a number of decades now. So I'm going to try and impart some ideas on that. I'm going to talk about the house, and also just finish off with a few ideas about some trends as we see them. So the sort of big picture theme really is what I've kind of grown to describe as biogenic home delivery, okay? So just using a play on words really, but it is very much focused on that renewable timber-based thing. And the kind of focus we've brought to it over all these years of trial and error is really combining timber factory and the sort of digital approach to things. So all these things are kind of combined. We're really interested in decarbonisation on a large scale, really. So we're not just talking about what we do in relation to the actual built environment. We're also talking about how that links with the landscape, with certainly the managed landscape, forestry in particular, but beyond that. Horizon circular economy is quite a good term, I think, because the decisions we make just now are going to affect at least the next couple of 100 years, probably longer. So it's good to have that kind of long-term thinking. So I think that horizon word is quite useful. Nature-based solutions, that's a kind of term that's being used commonly now, and it's really just to sort of underline the idea that you know, rather than fighting against nature, you know, it's a good idea to work with it really, and I think that's culturally becoming much more kind of understood, and really mobilizing towards climate action. So some of the things I'm going to talk about here in terms of the business structure and how we work, we're really keen to try and encourage more people to be active within the sort of built environment sector, because it doesn't have a great reputation, and we really need to change that because it should, and it's really exciting to build things and build beautiful things and things that are practical and change people's lives, frankly. So unashamedly, I'm going to talk a bit about business, because I think business has a capability and a power to kind of change things, particularly just now. And the best manufacturers in the world are, there's no doubt about it, are Toyota, the car assembly company, and they've developed a culture around lean manufacture, which some of you might want to dip into. I don't have much time to speak about that just now, but it's really based on a number of interwoven themes. So long-term thinking is one of those, so a philosophy around things. Every good business has that. The right process produces the right results. Now, there's not enough focus on process generally, in my view, and we talk about process innovation here. There's far too much talk, in my view, on materiality and product very often. We add value. Value is what we produce in businesses, and that's what our customers pay for. And we do that by enabling our people and our partners, so the people we work with closely. And generally, as architects and people working in our sector, we're continuously solving problems effectively. So we need to be kind of proactive about that and see that as a positive thing. So at the center of the MAKAR approach to solving problems is really a workshop space. My own kind of personal situation is that I started as a mechanical engineer and then went on to study architecture, and then did a sort of ridiculous thing and set up in business immediately after finishing my studies. So I wouldn't necessarily recommend that, but it's a good way to kind of learn about life and what not to do as well as what to do. But so what I've done really is combined that production mechanical engineering with design. And so we are talking about, you know, what is design? We don't necessarily need to go right into that, but it really is about the kind of initial intention. And the trick is to actually take that initial intention all the way through to fruition, really, which is what MAKAR's really trying to do. There's certain things that we can do in a workshop can't really be done on site. I think that's a fair point to kind of mention. So when we're talking about quality, continuous quality and continuity around that, there's a real advantage working in a workshop environment. The two previous presentations really we're looking at different construction types. I'm going to run through that in a moment, but just to kind of mention at this point that one of the things that we've done up here is we've looked at the resource that's available in relation to the primary processed timber availability up in this part of the world, and we've responded to that as designers. So we use solid timber very often, so it's very simple. What we call a timber batten. We can get it at 45 by 245 dimension, which is a standard, and we get 225 and 195 and etc. But the 245 is one that we use, and that's what you're seeing there. And there's also a small number of technical innovations that have allowed us to develop some of the kind of closed panel type systems that we use, which you're going to see in a moment. Another important thing in terms of the way we work as an organization is a team approach. So what you're seeing there is a number of people talking about how we resolve particular issues. So the way we look at that is self-managed teams with operatives working in a wide range of capacity. So we're talking about design, technical, production, assembly, working together to kind of solve problems effectively, which is a real strength, a kind of integrated strength. And we end up with solutions like this. So this is a roof panel with the roof finish and with PVs actually attached within the workshop context. They then go out on site and the building is watertight as soon as it's assembled. So we just touched on that. Jay just touched on the panelized approach. So that's what we employ. Main dimensions of panels are 3 meters wide, which is easy enough to transport on standard roads, and we make them up to 8 meters long. Yeah, ambitious quality standards. I'm not going to go into the same depth as the other excellent speakers because you've had all that. But you know, you've seen these terms already. So we're particularly interested in moving on that journey towards net zero during this decade. It's really, really important. Passivhaus we've talked about. Upfront and operational carbon's already been covered, so I'm not going to talk too much about that. In terms of timber and timber products, this is something that's been a bit of an obsession really with myself and MAKAR since the very start. So we have an astonishing ability to grow trees in the UK. I read something recently that trees grow about twice as fast in the UK as they do in somewhere like Finland. And that's not to say they're any worse than Finnish trees, they're just different. I think that's a kind of important point. So what we really need to do is to recognize what we have here and respond to it. I think that's rather important. I'm just going to talk about that a wee bit, and just to kind of fill in a wee bit of kind of information on that. So in the UK, we have 4 commercial species. So there's different species within this, different types within the same species. So obviously we've got pine, we've got different types of pine. Spruce is usually Sitka spruce, pine's usually Scots pine. Fir is normally Douglas fir. You're seeing that at the back of this image. And the larches, they're from Europe. We have European and also a hybrid and a Japanese form. These 4 species are really complementary in terms of their characteristics and their potential deployment within housing. And we're very often using at least 3 of those in our houses, because we don't use chemical treatments at all in any of our specification. So what we're looking for is a naturally durable material, usually larch, in places, in environmental conditions where we need that, and where we've got drier conditions and conditions where moisture is controlled, we can use some of the less durable materials such as spruce and pine. But the great thing is that they're complementary. There are other things as well in terms of species available, but they're less relevant, and also the hardwoods, obviously. I'm just going to say a wee bit about construction types, because I think it's worth just running through very quickly. Up in the north here, we build most of our houses with a timber panelized system, but most of it isn't particularly advanced. So a lot of it's an open panel kind of system that's assembled on site, usually quite badly, frankly, and it hasn't really evolved particularly well. So there's a number of companies, there's probably 10 or 15 or so in the north that are interested in that advanced approach. So we're using off-site methods, and to greater advantage, really, I would say. So we've got all the kind of benefits that we've already covered this evening. Other forms are timber post and beam. So some of you, I'm going to show some images of these hybrid types and also massive timber types. Just a quick word on durability, because this usually comes up when talking about timber. I believe the oldest timber building in existence is about 1,500 years old. Like most materials, I think it's fair to say that moisture basically kills buildings. It doesn't really matter what construction type they are. If you've got moisture in the wrong place in a concrete building or a brick building or a steel building, whatever, you're going to have problems. It's the same with timber. So timber management is hugely important in timber structures. The image there shows some Norwegian farmhouses. They're a couple, 200 or 300 years old. And so if you know what you're doing with timber in terms of how it's managed over a long term, then they last a very long time. It's also inherently repairable. So I've been in these these type of Norwegian farmhouses that are several hundred years old, and a lot of it's been replaced, but they're replaceable in that sense, which is rather important. Panel construction, whether it's built on site or built in a factory, you end up with punched out windows and minimal amounts of glazing, effectively, for stability and racking strength. I'm not going to go into that too much because most of you all know about this. Post and beam is a lovely way to kind of open up space, and you can live with these lovely structural elements within the house. It's more expensive, probably a better way to. That's one of our. All of these images, by the way, are projects we've developed over, or we've delivered over the years. a kind of more effective way to approach a kind of combined system, in a sense, is a hybrid system where you're using a combination of panel and post and beam or frame. And here's a kind of example of that, where you're able to open up more glazing in some parts, and also you've got a well insulated envelope in parts of the building. another example of that, where you're able to open up a building with a frame structure, which kind of gives it that opportunity, really. Massive timber, we've already touched on CLT. The other forms are kind of Brett Staple, which you're seeing there, and also nail lam. And what we've looked at, really, I think this kind of relates to the kind of concept of MMC, modern methods of construction and offsite. And what we've kind of discovered is that the development of a lot of these kind of types of materials was consistent with also the development of offsite approaches. So it's that idea of process and materials kind of coming together, really. And a lot of these forms are particularly well suited to workshop conditions. I mean, if you look at that panel there, it doesn't look like it, but it's probably going to weigh 1/4 of a ton. So you have to be able to move that around somehow. So that starts to define how you actually work with these materials. We've done quite a lot of work up here with forms from local materials. There's a kind of Brett Staple panel being tested down at Napier University in Edinburgh. So we've done all this work. It's just never been commercialized, and I think that's one of the opportunities, really, in the coming decades to actually take some of these ambitions and actually make them work from our own materials here. And that goes for insulation materials as well as structural materials. It's rather important. So moving on to Geanaisean, that in Gaelic, that means the place of the cherry tree, by the way. So that's a bit of a kind of a bit of an insight into the place itself. So as you see, it's a kind of wooded place. So on the edge of a village, about 20 miles from Inverness. So the top image there is just showing the kind of site. It's a long, thin site, sort of north-south. And we were able to position the house and the workshop in a position that was, its orientation was quite favourable in relation to Passivhaus approaches. This is the only drawing I'm going to show, so this is pretty kind of basic stuff. But it's a 1.5-story house with bites taken out of it. Form factor, we've already talked about that. It's really, really important. But up in the north here, we're really keen to have covered outdoor space on the edge. We inhabit the edge of buildings really quite well. What else can I say? It's not a platform construction. You can't really see that here. But we tend to go full height with the wall height, and then we drop the floors in. This was a bit of a theme with our buildings, this kind of curved ridge. Yeah, there's various things you can say about that. It's not the easiest thing to build. Okay, we've already covered this, but in many respects, Passivhaus to us is really about comfort. It's about that whole idea of producing very, very comfortable, joyful spaces, really. And as architects, we need to remember about that inspiration side of things. I'm going to talk about that in a moment, but the kind of 4 happy collisions really are huge amounts of insulation. Thermal bridging is hugely important as well. That's down to understanding how buildings go together and refining that. Air tightness we've covered, and obviously the mechanical ventilation heat recovery. This is an image of the kind of wall panel going together. So what you're seeing there is a scrim net over a cellulose insulated frame. So that's the 245 frame I mentioned before, and you've got 180 millimeters of rigid fiber insulation. That's a Pavatex system, and that gives you a 425 millimeter insulated fabric, which is pretty chunky, frankly. The next image, I think, shows the roof panel. So it's very, very similar. You can see the 245 here. There's an OSB, an 18 millimeter OSB for the air tightness layer on the inside. That's giving you the racking. So in actual fact, the wall and the roof are actually very, very similar. That purple strap is an Austrian element. Most of our technical innovations come from Europe, frankly, screws and tapes and lifting systems. And yeah, these cost about 45 pence each and can lift about 2 tons. There's a number of panels just about to leave the workshop, and they go into lorries and off they go to the site. Here's the house assembled. There's PVs on the roof. There's thermal panels on the roof as well. I'm not going to give you any stats on it, but it performs pretty well. Probably the biggest kind of thing is the fact that the customer is delighted with it, and it meets his needs really. It was mentioned previously that there was a bit of kind of ASBP kind of awards around a number of these projects. Larch Corner was also did very, very well, and this particular house picked up the sort of overall award last year, roughly this time last year. So I'm using just a couple of slides here, which we used at that award ceremony. So part of that consideration for the award was around resource efficiency. So we've covered quite a lot of topics on that already, but really material miles are quite important to us. So most of the stuff that we actually employ comes from the Highlands. Some things annoyingly don't, and we have to pull them in from Europe. And our real ambition is to actually do more materials from the UK, from Scotland, as we go forward. It's rather important that we do that, and we're making good inroads into that. So the rigid insulation, for example, is one of those materials that gets pulled in from Europe at the moment. Adaptability, housing, we need to be able to move things around. So if we can minimize load-bearing internal partitions, it's quite a good idea, so we can kind of move things around. Buildings want to change, they desire to kind of change over time. And if they're going to last for 100 or 200 years, as been suggested, which I completely subscribe to, we need to make sure that happens. I've mentioned circularity already. Social value. This is a house and a garden in a village, so it has that kind of relationship. The people side of things in relation to the kind of work we do, the work we do is meaningful. Everyone's engaged with it. It's high skill. It's well paid, which is really important. That kind of pulls people in. You know, we really need to have. We've actually got, I put on the chat actually, we've got 2 young women working in our workshop just now. One's an apprentice, one's just finished. And that's really joyful to see that kind of gender balance starting to happen. It's not easy. And also, you know, it's this move towards what we would call an ecological society. So it's, you know, it's ambitious, you know, what we're trying to do. All the speakers tonight have been ambitious in that regard, I think. Progressive trends. How long have I got, guys? Have I got another 5 minutes, or? I've lost my timing. I can't actually see it.
Another 10 minutes. How about that, Neil?
Thanks, Lynn. That's really, really helpful. So yeah, what do our customers value? And I think it's easy as architects to forget, you know, we're obsessed with technical things, you know, and we've talked about that a lot tonight. But in actual fact, you know, we mustn't forget that most of our customers, the image, by the way, is a small group of affordable houses that we built probably 5 years ago now for a local charity. And the kind of funny story was that we did a brief radio program on Radio Scotland, and we kind of turned up unannounced at one of these houses, and the radio presenter invited himself in effectively and spoke to the young mother with a kid running around. And he asked the question, you know, what does your house cost to heat? And she looked at him and said, nothing. And the kind of story is that there's a small wood burning stove that was heating the whole house, and her partner was basically managing to source pallet wood from his work, and they were able to heat the house virtually for nothing. So it was a kind of low cost kind of running house. But you know, that's just a little kind of anecdote, but it kind of says something about the kind of performance that we're able to achieve now. Imagine houses that almost cost nothing to heat. It's fantastic. digitization is really important. It's important to you young folk on this call, I'm sure, more than oldies like me. But I mean, the power of embracing digital and that what that actually provides in relation to integrating the design through technical through manufacture and installation is incredible these days. So it's really, really powerful, and that's something that we have to use at all opportunities. Here's an example of that. It's really, we've done a number of service modules. If you can try and get the services into one area in the house, if you can. So here's it's been drawn here. I don't have much time to talk about this, but what we're trying to do with services is optimization, really. And once you've actually built a house with a fabulous fabric, you don't need much else. You've got ventilation, you need to heat some water, and very small amounts of space heating. And the idea is to optimize that equipment as much as possible. So that's about servicing it properly. It's about maintaining it, replacing it when you need to, and also remanufacturing in that circular economy kind of way. And the idea is, if you actually know exactly how it's been built, as you do if you digitize it, you can actually do all those things very much better than you can do if it's deeply embedded within a structure. So there's that particular module heading out on a lorry. That's the corner of a house. It's finished inside and out. The more you can do off-site in that kind of respect, the better, in my view. Then we're also talking about energy positive and carbon negative houses. And Mark's already talked about how difficult it is to kind of say things about that whole carbon thing. But as we move through this decade, we're going to get really good at this stuff. I'm absolutely convinced of it. The energy positive idea is a house actually producing more electrical energy than it consumes. And we're actually doing that quite easily just now. So all electric houses is obviously the way to go. It's much easier to integrate electrical devices and look after them. And that's the route that we're taking now. So it's intelligent hot water systems, infrared panels that actually heat the fabric instead of the kind of space heating in that sense. Induction hobs and battery systems. We're using all of these systems now to good effect. And just to finish off, this is some work we did in lockdown, actually, the first lockdown, with a bit of headspace. So we've looked into what we call a 2-bed starter terrace. And Mark, well, both previous speakers who are much more knowledgeable about Passivhaus talked about this. And this is a lot to do with the form factor. So once you get into kind of terrace forms, the whole kind of fabric starts to work a lot better for you. And we also have this kind of housing crisis, very much so in the north here. We've really let down the kind of number of multiple generations with lack of housing and lack of decent housing. So one of the things we're looking to push forward as a business, a kind of business to business offering, is the idea of a number of different terrace forms that are useful in urban and rural Scotland. So I'm not going to say a lot more about them, but the characteristics they have relate to all the things that we've talked about really on this call, which is, I think, been incredibly informative for all you guys, I think, and I wish you all well with the competition. It looks fantastic, and I wish we had that kind of thing when I was a student 30 years ago. But there you go, that's how things change. Back over to you, Lynn. Thanks very much.
Thank you very much, Neil. That was really nicely put. Lots to think about. Funny you should say that, actually, because I did a session for TAB last week on the intro, and I remembered that I'd won the UK's first zero CO2 housing competition, but it was 22 years ago. And, you know, we still haven't got them, have we, really? So yeah, there's always work for us designers. Indeed. Okay, so I've made a few comments to ask you, Neil, about your system, but I wonder if I'm not picking up any specific comments actually about your presentation. So I wonder if we could just go back to this thing about the thorny issue of the of the ground to wall junction.
Yeah.
I wonder if you all, my speakers, could comment on this issue of, you know, how do we drive the CO2 out of the wretched concrete, given that we're
Can I start on that, because I meant to mention it.
Please.
I meant to mention it because the house I just showed, I didn't mention it's on a ground supported slab, and it was really frustrating because we were kind of pushed down that route, apparently due to the requirements of Passivhaus, but I've since learned that's a load of nonsense. Anyway, most of our houses are built off the ground, and we usually put in a 3-meter grid of pad foundations, and we have done the analysis through Ecolab in recent times. We're doing a piece of work, by the way, with Edinburgh Napier University called the Homegrown Demonstrator House, and this is looking at how we optimize these very issues, and that's an example of that. And we absolutely minimize the concrete, but we still use a concrete pad with a concrete footing, but it's on a 3-meter grid, and then the floor panel spans the 3-meter in both directions. That's the way we're working just now.
Can I say something on the subject?
Yeah, please, because there's stuff about ventilation underneath and all that, but as long as it's well insulated, then that's fine, isn't it?
Yeah. In terms of, you know, a lot of people will say, oh, what you need is just to reduce the cement content. As I understand it, the substitutions, there's not sufficient of those substitutions for that to be a universal solution. So it would only be a small proportion of people that could take that route anyways. We did try on we were doing the carbon audit of one of our projects, and we put a 50% cement replacement, and actually we still weren't at the RIBA 2030 level of embodied carbon, even with replacing a good proportion of the cement. So it's a problem whichever way you look at it, and I think this idea that you can do cement-free concrete is a little bit of a false promise. I think we need to think of ways of lifting and having, just like Neil said, really finding slightly different solutions to groundworks.
Yeah. I mean, one of the solutions that we've considered is actually using CLT as the slab and putting that on top of the insulation formwork. But the issue that you start to arise is what happens if there was a leak in the house, and issues can start to arise there, and then you've got secondary questions in terms of insurers. You've got that kind of issue, and I think that I think when we start to get into it, then we start to get into issues of professional liability and indemnity insurance, and then it all gets very haywire quite quickly. So one thing I will do is I'll say that I know that Beth Williams is doing a presentation on a concrete-free foundation system strategy that she's developed, and she's presenting it later in this series. So I would watch for that presentation intently, because I know that it's pulling in from different experiences out in continental Europe, whereby they're using, I think it's aggregates that and then basically sleepers and systems like that to help create concrete-free foundations. So that'll be interesting.
Okay, sounds like Tabitha's on the case if she's already got that one lined up. So just generally about the use of timber, I mean, in terms of our current skill base, what we're saying really is that as long as you've got that quality control in the, presumably mostly in the factory environment, and you've got a system that's really well designed, as a system, then that's that it's not like anybody could do it, but it's not like rocket science. Do you want to reflect on skills, because there's a lot of fuss from some quarters that net zero is hard because we haven't got the skills, but it'd be good to just hear a bit of your view on that.
Yeah, I can say something on that. I mean, buildings are sophisticated things, there's no doubt about it, and they're not low skilled. It's not a low skilled kind of focus really. So, but at the same time, in terms of having people engaged in their work, and the term we use is meaningful work, you know, there needs to be a level of skill there. I mean, what we're actually doing is the kind of approach is mass customization is probably the best way to describe it. So most of the time when you talk about standardization of components and workshop kind of approaches, a lot of architects get quite worried about that because they think it's going to stop. It's going to reduce their options. In actual fact, most good designers already reduce their options by trying to do a few things well. And the fact is that if you standardize the relationships and open up the patterns to multiple outcomes, that's the way to approach this. So if you take a window in a panel situation, get that absolutely nailed in terms of the best solution. It doesn't matter where that window goes in the panel, but it always goes in the same relationship. So it gives you that opportunity to change the pattern. You can basically build anything, but you're using the same standardized approaches. That's the way to look at it, really. I think that's the grown-up way to look at it.
Yeah, I think poker yoke, I think, is the term, Neil. Mistake proofing. You know, it's having a system that allows that strategy to be implemented. Yeah.
I think there is so much for the architect to contribute in terms of how the overall design happens, that to be sniffy about using a system that's going to give them a very good solution is just not helpful. And we need to work together. It's always about working. I think, Neil, in your talk, you really brought this ideas about people working together and respecting one another. And that's what we need to do, rather than think I'm going to do it all, because it's just not like that in the built environment.
No, you've got to be hugely collaborative. I think on any passive house related project, any very low energy project, any project that where you're going to close performance gaps, any project where you're going to deliver high standards of comfort for your clients, any project that you're going to deliver on budget, you know, any of those things, if they apply, and they always do, then you have to collaborate very closely. And the more people that can be in that first meeting, the better in many respects.
And that kind of touches on skills as well. And because, you know, while what we do as designers and technical people is skillful, what people do in putting things together is also incredibly skillful. Sure. And what we need to do is get rid of that hierarchy and kind of recognize that everyone is a very skillful thing to contribute. Yep. So, I mean, we often have the guys on site, you know, that fitting out kind of process is a very, very skillful thing. I mean, finding the right people to do that is very, very difficult these days. And you know, what we do is they're involved in the discussions about how to improve these things. Like, they're given, you know, complete control, you know, the kind of you know, that personal management skill kind of side of things. I mean, organizations are changing away from this top-down, you know, triangular kind of management structure to individual management, you know, where people are taking initiative and actually creating value themselves and actually working together. These are really, really positive things. And it's so good to speak with a group of people that completely acknowledge that. You know, this is the future of organizations, frankly.
Yeah.
It sounds so much more attractive as well, doesn't it, as a working environment than the business as usual model.
Yeah.
One, if I could just bring us on to one aspect, which I was just involved in the Home of 2030 competition, which of course Moby were involved with as well. But one of our key things was the adaptability, and I noticed you mentioned that, Neil, which is kind of not so well kind of explored, I think, by clients in my experience. But yeah, I mean, if we're really building buildings that are going to last centuries, then actually having that adaptability, and it seems like timber is a very good system from that point of view, isn't it? So actually being able to flex over time and have that future potential is really a really good attribute, I think. So I don't know if you want to say a bit more about that.
Well, the book, the reference that everyone should have is Stuart Brand, how buildings learn and what happens to them after they're built.
Yeah.
Stuart Brand's an absolutely brilliant thinker, American kind of future, absolutely fabulous guy, big mate of Brian Eno, by the way, and which gives you a clue. Yeah, it's a difficult book for architects to read because it goes against pretty much everything they're taught, frankly. But it's a fantastic book to dip into, and it sounds like Mark knows all about it. But I would absolutely recommend it, because buildings are trying to change the whole time, and we don't look at them as if they are. You know?
On that very point, How Buildings Learn, the whole series is also available on YouTube, because it was also a BBC series. So if you can't get hold of the book for whatever reason, you can watch all of the videos. And I implore every single person here to watch all of them, soak them in, take notes and watch them again. It will fundamentally change how you think about architecture, and it's vital if we're going to develop buildings that are sustainable for the future.
Can I just slightly step back one step and just say something about the hierarchy business that Neil was talking about? I'll just say it very quickly in 2 sentences maybe, is the importance of breaking that hierarchy between architects and the contractors and builders on site. For me, that's one of the fundamental things that needs to change and be much more respectful and much more equal.
Yeah. And I'll say this, having been a labourer on a building site, having been a cost estimator, having been an architectural technologist before I became an architect, yes, we can go on site and we need to be able to look everybody in the eye. And it doesn't matter whether you're laying a paving flag or waving a piece of paper around, you're all equals under the sun. And we've all got roles to play and we can help each other out. Fundamental. No egos. Egos are the death knell of any project.
Well, I think that's a good note to leave it, actually. I think I'll hand back to Tabitha to tell us about the goodies she's got lined up to come. But thank you all. Thank you 3 very much for your excellent presentations. Over to you, Tab.
Thank you all so much. Let me just screen share. And it's this one, and then go share. Are you seeing what I'm seeing? Just one screen with all our fabulous speakers on tonight. Fantastic. Huge thank you, Lynn, and Mark and Jay and Neil. It's been such a masterclass. I have learned so much. Whoops, I've just stopped sharing. I didn't mean to do that. Obviously, I got very excited, as is my wont. Right, and I need to go and do it all over again. Let me start again. Now I've got no idea what I'm doing now. Let me go stop share, and then I'm going to try and do that all over again. Right, now I will try and do the right thing.
Yeah, that looks more promising.
Somebody has to get it all wrong tonight. It has been perfect. So somebody has to, I'm not going to swear, mess it all up. Huge thank you to all of you. And just going back to the competition. So this is your Riverside Sunderland site, the area marked out in red. You know, this showed you where the city centre is, and you know, where the as where the river is. And it's the red area that we're looking for you to design your indicative master plan on. And please don't panic. You know, we want this to be fun. We want this, all of us, to learn together. We're asking you to work as a team. We have landscape architects signed up. We have engineers, we have mechanical engineers, civil engineers, we have interior architects, we have architectural technologists, we have construction professionals, we have quantity surveyors. So one way or the other, we will help you find a team. It's an indicative master plan, so don't go overboard on it. But we want you to design and engineer and detail and cost one family 3-bed home. And that's where we want you to get into the detail. And so now I'm going to be curious. Are you going to go solid timber frame from the UK? Are you going to use CLT? Mark's sort of nodding his head. Or are you going to go I-joist? Or are you going to come up with a mixture of all 3 or something completely different? And so that is the end of this week, which has been Desirable Homes and Communities. And we have gone through, starting with Goldsmiths, into the Home of 2030 concepts and into current buildings that are way ahead of the field. I'd like to thank our sponsors because I couldn't have put this on without them. So the Confederation of Timber Industries, which includes the Structural Timber Association, the Timber Trade Federation, and the British Woodworking Federation and others. For Akoya, who will come and speak to us next week about modified timber. From Rothablas, because they supply everything for buildings apart from the timber, well, and the windows. From the Timber Decking and Cladding Association, Janet will be talking with us next week. For PEFC, who provides sustainable certified timber. They talked to us last week. For the Alliance for Sustainable Building Products, will come and talk to us next week, and about natural insulation too. And for Wood for Good, who provides so much good information on their website. And for BSW, who I saw in one of Neil's slides, who provide homegrown timber. Tomorrow night, we have our virtual pub. So I encourage anybody who's been with us during the week and any of our speakers or chairs to come and join us, come and let your hair down, have a very informal evening and just come and talk about what you've learnt. We encourage students to start to form teams. And last week, it was such a joy. You had me in tears. Sorry, I do get emotional about it, but I'd just like to say thank you all. And I've posted week 3 in the chat. I'm just going to stop sharing.